Welcome back, everybody. In this video we're going to be talking about applications of inequalities in algebra. I'm going to show you some examples here where some of them we're just going to set up the inequality, and then others we set up the inequality and then solve. Let's look at this first one here. The length of a rectangle is 3 times its width. The perimeter of the rectangle is at most 110 centimeters. What's the inequality that models the relationship between the width and the perimeter of the rectangle? Well, maybe first we should talk about the perimeter of a rectangle. We all know that if you add up all 4 sides of a rectangle, you get the perimeter. That would be width plus length plus length. So think of this as 2w plus 2 times L, the length. Now, at most 110, so we're going to put 110 in for the perimeter. The inequality that goes with the phrase at most is less than or equal to. I know that's a little bit counterintuitive. But they say in the first sentence that the length is equal to 3 times the width. So whenever we see L in the inequality, we're going to substitute in the quantity 3w. Just like that, we're still multiplying it by 2. We still have the other 2w. Now notice the only variable we have is w, and the perimeter here 110. So this answers the question. This sets up the inequality that relates the width and the perimeter. 2w plus 2 times 3w less than or equal to 10. Alright, and we're just setting this up. If you did need to solve for w or L for that matter, you certainly could. But we're just setting it up. Next one is a business problem, and in business the goal is to make a profit. It says Tom started a business selling figurines. He spent $4,500 to obtain his merchandise, and it cost him 200 weeks for general expenses. Okay, so those two numbers there are his expenses and his cost to run his business. He earns $460 per week in sales. So what is the inequality to model this problem if Tom makes a profit? So in business, you'll make a profit if your earnings are greater than your costs. Alright, so what you earn needs to be greater than your costs. Well, in this problem, there are 2 types of costs. There's the $4,500 that Tom had to just put up to get his business going. We add to that his weekly expenses, 200W, 200 times the number of weeks. But then he's going to earn 460 per week, 460W. And there's the setup. Notice how what he earns needs to be greater than what his costs are, and that will tell us that he gets a profit. So we're just setting this up. We're not solving it. If we were going to find what's the number of weeks he needs to work as business to make a profit, we certainly could solve for W. But they don't ask us to in this one yet. Alright, next one, we have an age problem. Ron is 3 years older than twice his cousin Jack's age. The sum of their ages is less than 30. What's the greatest age Jack could be? Alright, so let's use an R for Ron's age. Let's use a J for Jack's age. And if we add those together, we have to be less than 30. Okay. To figure out what Jack's age, the greatest age Jack could be, let's make an equation that relates Ron and Jack. It says in that first statement, Ron, R, is equal to 3 years older than 2 times his cousin Jack's age. So Ron is equal to 3 plus 2J. I'm now going to put that quantity, 3 plus 2J, I'm going to put that in for this first R right here. So we have 3 plus 2J plus the original J for Jack's age, and that's still less than 30. Let's go ahead and solve this inequality. 2J and 1J make 3J. I'm also going to take away that 3 from both sides. Kind of show that here. And now I'm down to this simplified inequality, 3J less than 27. I'm now going to divide by 3. Jack's age has to be less than 9. Okay, well the next age less than 9 is 8. Alright, so Jack has to be 8 years old. So the highest age he can be, because the math here, the inequality told us it has to be less than 9. Jack has to be 8 then. Let's look at another one. Sum of two consecutive integers is at least 185. Is there that phrase, at least 185? It's asking what's the larger of the two integers. The at least means greater than or equal to 185. That's our inequality that we set up. We have two consecutive integers. We'll call one n, and then the next one after that would be n plus 1. That's what we mean by consecutive. That's how numbers work? You know, consecutive 4 and then 5, you just add 1. Consecutive 6 and 7, you just add 1. But we want the sum of those two. We want the sum of the two integers, so we're going to add those two together, the two expressions for the integer. Okay, n plus n, then 2n. Take away 1, take away 1, and we're greater than or equal to 184. We now need to divide by 2 to figure out what that first integer is. N has to be greater than or equal to, and it looks like 92. Alright, so the smaller integer n is 92, but the larger one would be n more than that, 93. There we go. 93 is the larger of the two, 92 is the smaller of the two. Alright, let's do one more here. It says Valerie has scored 45, 32, and 37 on her 3 math quizzes. She will take one more quiz, and she wants the quiz average of at least 40. She wants to have an average greater than or equal to 40. That's what that phrase at least means. What's the minimum score she needs to earn on her fourth one? When you find an average, you add up the 4 things together. Here's the first quiz. Here's the second quiz. Here's the third quiz. And then let's use X for that fourth quiz she has yet to take. Average it. When you find the average or the mean of any set of data, you add up the set of data, divide by the number of numbers, which is what we did here. 4 items, 1, 2, 3, 4, divided by 4. We're going to solve for X then to answer this question. First we need to do is add 45, 32, and 37. And that gives us 114 plus the X. I'm going to move that 4 to the other side. I'm going to do that by multiplying both sides of the inequality times 4. And that gives us 40 times 4, which is 160. So we're greater than or equal to the 160. Last step, take away 114 from both sides. 160 minus 114 gives us 46. So Valerie's score on her last quiz needs to be greater than or equal to 46, or another way of saying that is at least 46. As long as she gets a 46, she'll have her quiz average to be 40, which is what she wanted. All right, I hope this helped understand applications of inequalities a little better. Thank you for watching.